everyone. We're going to work through a practice problem now for the X-bar and the R charts in two different sections, and this is section 1. So we are working in a food processing plant, and it's our task to control the weight of jumbo ravioli packages. And we've got data that has been collected on the weight of 4 different packages, approximately every 30 minutes. So we have here 7:30, 8:15, 4 different packages weights, and we have 15 different subgroups available. And the weights here are all in ounces. So the first question is, what here is our sample size? Is it 15 or is it 4? So every half an hour or so, we're collecting data for n equals 4. So our sample size is 4. And we have 15 subgroups. Now, some of you may remember from the last lecture, we were talking about needing 25 subgroups. So here we only have 15. What do we do? So this is the data that we have. We move ahead. We continue with the data that we have. Ideally, we would like to have, before setting up a control chart, 25 samples. So we would try to collect more data. We would try to find out why we only had 15. Is it possible to get more data right away? But for this example and for in practical real life, normally you don't always have perfect data. You use what you have and you recognize the limitations. So our task is to roughly sketch the X-bar and R control charts to monitor the weight of this ravioli package and to comment on the results. So all the data we just saw in the last slide. Now, what do we do first? What do we do with this data? So, to help everybody out, we have already gone through the data. Here it is again, 4 different packages, and then different trials. For every sample, so for sample 1 here, we've calculated for you the X-bar value. So for this first sample collected at 7:30, we had an average weight of 35.1 ounces, and we had a range of 2.2 ounces. For sample 2, it wasn't quite the same. We had a slightly lower X-bar sample average and a slightly narrower range. So we do this for 15. And as we just showed in the last lecture, we can already calculate our average of the averages, are known as X-bar bar written out. And with all this data, if we go ahead and calculate the average of all of these sample averages, we get 35.72 ounces. And likewise, for the range, we look at all these range values. So range bar is 2.02 ounces. So that's the first key pieces of data that we can obtain from our table here. So now what do we do next? We've got n equals 4. We've got X-bar equals 35.72. Our R bar is 2.02. Now we need to calculate the control limits, and we'll do that in part 2. But let's just remember that the upper control limit is equal to X-bar plus our constant A2 R bar. The center line, X-bar, and the lower control limit, X-bar minus A2 R bar. This is for the X-bar chart. And for the range chart, the upper spec limit is going to be equal to the constant D4 times R bar. The center line is going to be just R bar, and the lower control limit is going to be D3 times R bar. These are for our R chart. So in the next part of the example, we will look up those equations and we will complete our control charts. Okay, see you then.